Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are studying another topic 13.9, conversion of galvanometer into ammeter. Okay, what is an ammeter? Ammeter is the device by which we can measure the current. We can measure the current. This device is called ammeter. Okay, remember, for accurate measurements, ammeter should be connected in series with the devices. Ammeter should be connected in series with the devices for the accurate measurement. Suppose if we have a bulb and we connect an ammeter in series with the devices. So look at this circuit. This bulb, the current passing through the bulb, we don't know. So if we want to find the current passes through the bulb, we should connect the ammeter in series. So look at here. We connect the ammeter in series with the bulb. So ammeter say that 5 ampere is passing through myself. Ammeter say that 5 ampere current is passing through myself. So if the 5 ampere current is passing through ammeter, it means the 5 ampere current will also be passed through the bulb, because in series the current is same. 5 ampere is passing through the ammeter, 5 ampere will pass through the bulb also, because in series the current is always the same. Okay, now we are studying the construction, how we can construct an ammeter. So remember, it is the modified form of galvanometer. Modified form of galvanometer. Ammeter is a modified form of galvanometer. How? Look at here. If we have a galvanometer, so connect a shunt resistance in parallel to the galvanometer. If you connect a shunt resistance in parallel to the galvanometer, so this whole device is called the ammeter. So this whole device is actually the ammeter. Okay, what is meant by the shunt resistance? The shunt resistance means very minimum resistance. The shunt resistance means negligible resistance. It is very negligible resistance. So why it is connected in parallel? For the safety of galvanometer. Okay, so when you connect a shunt resistance in parallel to the galvanometer, so this whole device is called ammeter. So this is actually the ammeter. Now I am going to discuss the range of ammeter. So look at the circuit. This is the galvanometer and this is the shunt resistance in parallel. Okay, the total current I is flowing in the ammeter. So here the current comes, so the current here will be divided into two parts. Maximum current IS will flow through the IS and some current will flow through the galvanometer, that is IG. So which current is greater, IS or IG? So it means IS will be greater because the shunt resistance is smaller than the galvanometer. Okay, so the current is dividing between the two currents. So one is IS, the other is IG. So when this total current comes, so this current is dividing between the two path. So one current is IS through a shunt and the other current is IG through the galvanometer. Okay, shift the IG on the other side, so it will be I minus IG. Okay, so IS is equal to I minus IG. So look at here, these two devices are in parallel. So if these two devices are in parallel, so voltage will be same. So VG is equal to VS, voltage of galvanometer is equal to voltage of shunt. In parallel, voltage is always same. Okay, V is equal to IR and V is equal to IR. Okay, now divide IS on both sides. So we will get, if you divide is on both sides, so we will get ig rg divided by is. Okay, I divide is on both sides, so it come in the denominator of this equation. So putting the value of is from this equation, so putting the value of is, so rs is equal to ig rg divided by I minus ig. This equation is called the range of ammeter. This equation is actually the range of ammeter. It shows, this equation shows, if you want to find a larger range ammeter, so the shunt resistance will be very very small. If you want to make a smaller range ammeter, so you should connect a larger shunt resistance. So this equation shows the range of ammeter. So this is all about this topic. If you have any query, then you can ask in comment section. Okay, take care. Allah Hafiz.